All right. The Zoom session is being brought to you by the Fractal Inverse Bullseye Horizon. All right. For today, we begin chapter 5. This is it's completely different stuff. Before we had been talking about exponentials and logarithms. Now it's a kind of a flip over to a new thing. It's appropriate because we've just passed midterm time. And so now this chapter 5 is about linear systems. Much simpler, but a very different topic. 5.1 will be linear systems in 2 variables, and 5.2 is linear systems in several variables. We start with 2 by 2 linear systems. They're of this form: ax plus by equals e, cx plus dy equals f. 2 equations, 2 variables, therefore the name 2 by 2. A, b, c, d, e, and f are constant. What are x and y? So for example, x plus y equals 10, x minus y equals 4. 2 numbers whose difference is 10 and whose sum is 10 and whose difference is 4. All right, now 7 and 3 works. 7 plus 3 is 10, 7 minus 3 is 4. So 7 by 3 is a solution. Now, if you graph x plus y equals 10, you get this graph in the plane here, this line here. X minus y equals 4 graphs is this line here. All right. Now these 2 lines meet at 1 and only 1 point, and guess what? It's at 7 by 3. It's a solution to the system and the intersection of the graphs of each line. All right, so here's another system: x plus y equals 10 and x plus y equals 4. Here the graph is 2 parallel lines. They do not intersect. That makes sense because there are no x and y whose sum is 10 and whose sum is 4, because then their sum would have to be 2 different numbers, which is not allowed. So no solution exists. These lines don't intersect. That's what these mean. Parallel lines means no solution. Now here's another system: x plus y equals 10, 2x plus 2y equals 20. Now if you graph them, you get the same line twice, overlapping lines. They intersect along their entire length. These 2 equations are equivalent. They're actually saying the same thing twice. So there are many solutions, as many as there are points on the line. So overlapping lines means 2 solutions. So, okay, so you get a 2 by 2 system, you get a pair of lines. Either they meet at 1 point, or they meet at no points, or they meet everywhere. So here's an example of them meeting at 1 point. Here's an example of meeting nowhere. Here's an example of meeting everywhere. Now, there's a problem with these last 2. First of all, they're kind of an exceptional case. These 2 happen when the 2 lines have the exact same slope. If they have even slightly different slopes, they will meet at 1 and only 1 place. But here they're the same slope, and they meet nowhere or they meet everywhere. Now, there's a problem which I constantly run into. Please don't fall into this trap. For the parallel lines, you can say that there's a solution at infinity, sort of like how railroad lines seem to meet off at the edge of the horizon. All right, so they meet at infinity, whereas the overlapping lines, they're infinitely many solutions. These are entirely different. A solution at infinity and infinitely many solutions are completely different. Please don't confuse these. So therefore, please never ever write as an answer to one of your questions infinite solutions. It's ambiguous, and ambiguity is not your friend. Don't say that. Say no solution or many solutions, and that will do it. You might even say infinitely many solutions, but please don't confuse that with no solutions. All right, we proceed. Now, there are various methods of solving linear systems. Graphing, well, that's what these are. These are graphing solutions. They're terrible. Don't do it. Because if you solve a system by graphing, the accuracy is limited by the width of your pencil and the steadiness of your hand and the waviness caused by the grain of the wood on the table that you're working on. Ridiculous. It's not a mathematician's solution. It's a carpenter's solution. You can do much better. There's solution by substitution, which works well enough for certain types of systems in a particular form. Now, generally, there's something called eliminating variables, which we will get to. And it works always. And there's a variant of it where we use what are called matrices. There's another variant where we use what's called Cramer's rule. Both of these come back to eliminating variables. The eliminating variables always works. Substitution sometimes works well enough. And okay, so there we are. So starting with solution by substitution. First, we use one of the equation, let's say this one, to solve for x or y in terms of the other variable. So if x plus y equals 10, then y equals 10 minus x. That follows from this. Then we substitute this variable into the other equation. So you have x minus y equals 4. So you have x minus y, which is 10 minus x equals 4. That gives us one equation and one unknown. This we then solve by a set of steps. Here x equals 7. And we substitute back y equals x minus 10, and y equals 10 minus x, so y equals 3. And that gives the solution. So here, x plus y equals 10, therefore y equals 10 minus x. Substitute that y in for here. So y, x minus 10 minus x is 4. And then, okay, you distribute the negative sign, you combine, you just transpose the 10, x plus x equals 4 plus 10, simplify, 2x equals 14, divide both sides by 2, x equals 14 halves, so x equals 7. That's one variable. And to get y, the other variable, you plug in 7 for this equation. So y equals 10 minus 7, which is 3. Okay, now, one last step, and it's a matter of etiquette, you might say, or common sense. Having gotten the solution, please write it down in one place. X equals 3, y equals 7, y equals 3, or the ordered pair 7 by 3. Please write it down in circle so I can see it. Please, no, don't ever write x equals 7 in one corner of the paper and y equals 3 in the other corner of the paper. I might miss it and not be able to see the answer. Commit to whatever answer you get. That's solution by substitution. It works well enough when one of the coefficients a, b, c, and d is plus or minus 1. Otherwise, it's a pain in the neck because you have to deal with a lot of fractions. Now, the solution by elimination of variables. Here's how it works. You use row operations to eliminate variables. Here's what I mean by row operations. Given two equations, a equals b and c equals d, the one row operation consists of combining them. A plus k times c equals b plus k times d. Rescaling them is where you multiply one of the equations both sides by k, so ka equals kb. The idea is to use combination and rescaling to eliminate variables. For example, let's get back to x plus y equals 10 and x minus y equals 4. We already know the solution is 7 by 3. If we add the equations to each other, then x plus x is 2x, y plus negative y cancels. Y variable is eliminated. 10 plus 4 equals 14. Do we have 2x equals 14 to divide both sides by 2 and get x equals 7, and there you go, 2 steps. Whereas you can subtract equations, and x minus x cancels. Y minus negative y is 2y, so 2y. 10 minus 4 is 6, so 2y equals 6. Divide both sides by 2 and get y equals 3. And there we go. We have the solution. Only about 4 steps in all, whereas this seemed to take rather 1, 2, 3, 4, 5, 6, 7 steps. All right. Well, let's try this rather more complicated one. 5x plus 2y equals 11. 7x plus 6y equals 9. Ugh. Oh boy. None of these match up, and none of these coefficients are 1. So what we do is do some rescaling to line up some variables. We have a 2y here and a 6y here. We rescale the first equation by 6, this becomes a 12y. If we rescale the second equation by 2, this becomes a 12y, and these match up. So you rescale the first equation by 6 and get 30x plus 12y equals 66. Rescale the second equation by 2, you get 14x plus 12y equals 18. Now, since these y's are lined up, 12y and 12y, if we combine the equations by subtracting, then the y vanishes. We're left with 30x minus 14x is 16x equals 66 minus 18 is 48. 16x equals 48. Now, at this point, we divide both sides by 16, then x equals 48 over 16, so x equals 3. Now, we could, for instance, substitute into here and then solve for y by transpositions and so on. But let's use the same method for this. Now we want to isolate y, so we need to eliminate x. We have a 5x here and a 7x here. If you rescale the first equation by 7 and the second equation by 5, you get a 35x for both, which can be eliminated. So we rescale the first equation by 7. we get 35x plus 14y equals 77. We rescale the second equation by 5, so you get 35x plus 30y equals 45. So, okay, looks good. 35x plus 14y equals 77, 35x plus 30y equals 45. We can eliminate the x by subtracting equations. So we combine the equations by a subtraction. 35x minus 35x cancels. 14x minus 30x equals negative 16x. 77 minus 45 is 32. So negative 16y equals 32. So y equals 32 over negative 16, which gives us y equals negative 2. And the solution is x equals 3 and y equals negative 2. And that's done. All right, here's another example. Here's some examples. Y equals 3x and x plus y equals 8. Now, this is an obvious substitution because we already have one in terms of x. Y equals 3x. So we have a y here in the second equation. We'll substitute a 3x. Get x plus 3x equals 8. Therefore, 4x equals 8. Therefore, dividing by 4, x equals 8/4, which is 2. And substitute 2 in for x here and get y equals 3 times 2 is 6. Solution, so the solution is 2 by 6. And let's double check. 6 is indeed 3 times 2, and 2 plus 6 is indeed equal to 8. So the solution works. Here we have x plus 2y equals 6, 3x minus y equals negative 10. Now here we have a 1x, so we can solve for x in terms of y. So when we do that, we get x equals 6 minus 2y. We substitute that value of x, expression for x, into here where this 3x is. So substituting, we get 3 times x minus 2y, that minus y equals negative 10. This is one equation and one unknown which we can solve. First, distribute the 3. 18 minus 6y minus y equals negative 10. Transpose the 18. Negative 6y minus y equals negative 10 minus 18. So simplifying, negative 7y equals negative 28. So far, so good. Divide both sides by negative 7. Y equals negative 28 over negative 7, which equals 4. So, okay, you have a value for y. Then to find x, we plug in 4 in for y in this equation. So x equals 6 minus 2 times 4, which is 6 minus 8, which is negative 2. So x is negative 2, y is 4. Solves the system. And here we have another case of a difference in a sum. X minus y is 7, x plus y is 11. All right, this is fairly easy. We eliminate the y by by adding equations. X plus x is 2x, negative y plus y cancels, 7 plus 11 is 18. So 2x equals 18. Then divide both sides by 2 and get x equals 9. Sounds good. Now that's if we add the equations. If we subtract the equations, and x minus x cancels, negative y minus y is negative 2y, 7 minus 11 is negative 4. So 2y is negative 2y is negative 4. Divide both sides by negative 2, get y equals negative 4 over negative 2, which is 2. Y equals 2, x equals 9, so 9 by 2 is the solution to the system. Oh, here they're definitely being annoying. Twice a plus b equals 94. Twice a minus 9 equals 3b minus 23. Ugh, what a mess. Well, okay, the first thing to do is to simplify things by distributing this 2 over here and doing some distributing here. So from first equation, we get 2a plus 2b equals 94. Second equation is 4a minus 4 times 9 is minus 36 equals 3b minus 23. It still isn't quite right. Let's transpose the 3b to the left by subtracting. Transpose the 36 to the right by adding. And so the first equation is still 2a plus 2y equals 94. Second equation becomes 4a minus 3b equals negative 23 plus 36 is 13. 4a minus 36 is 3b is 13. Now we have it in the proper form for doing solution by elimination. First, let's start by eliminating the a's. We have a 2a here and a 4a here. So we just double this first equation and multiply the second equation by 1, we'll get 4a on both for both. Here we have a 2 and a negative 3, so we multiply by a 3 and a 2, so we'll get a 6 and a negative 6. Okay, for this first one, when we rescale by 2 and 1, we get 4a plus 4b equals 188. 4a minus 3b equals 13. The a's are lined up, so if we combine the equation by subtracting, these a's cancel. 4 minus negative 3 is 7, so 7b. 188 minus 13 is 175, so 7b equals 175. So you divide both sides by 7, b equals 175 over 7, so b equals 25. That's the first. Now, okay, for this, here we go to solve for a. Let's rescale the equation so the b's line up. So the first equation rescaled by b is 6a plus 6b equals 282. Second equation rescaled by 2 is 8a minus 6b equals 26. Now here I have a 6b and a minus 6b. All right. Now here, instead of adding the equation, subtracting the equation, let's add them. That way the 6b's will cancel. So when you do that, 6a plus 8a equals 14a. 6b plus negative 6b is 0. 282 plus 26 is 308. All right, next step, divide by 14. A equals 308 over 14, which is 22. So the solution is A is 22, B is 25. There we have it. Now here we have, now we're about to run into trouble. 0.16x minus 0.08y equals 0.32, and 2x minus 4 equals y. All right. The second equation, we transpose the 4 to the right and the y to the left. So 2x minus y equals 4. And this first one, to get this into whole numbers, let's rescale by 25. 0.16 times 25 is 4. 0.08 times 25 is 2. 0.32 times 25 is 8. So 4x minus 2y equals 8. 2x minus y equals 4. All right, now here we have a 2 and a minus 2 and a minus 1. So let's rescale these equations. The first one by multiplying by 1. Second one to rescale to multiply by negative 2. That way we'll get a minus 2y from the first equation and a plus 2y in the second equation. They're lined up to cancel when we add them, not subtract them. Excuse me. This is page 10. Add equations. My apologies. I'll change that in the canvas. So 6x minus 2y equals 8 minus 4x minus 2y equals 8 minus 4x plus 2y equals negative 8. When you combine by adding, that should be a plus, not a minus. Then the x's cancel, and the y's cancel, and the 8's cancel, and we're left with 0 equals 0. Everything cancels out. Now, when you get a 0 equals 0, that really means that the first two equations were really equivalent equations. They didn't say different things. So the second equation gave no further information. And therefore, there are many solutions. The lines overlap, so there's infinitely many solutions. Oh, suffice it to say, many solutions. Now, let's do a slightly different one. Y over 4 equals 1 plus y over 5. X over 4 equals 1 plus y over 5. X equals 4/5 of y plus 10. First equation, we rescale by multiplying by 20. And after some cancellation, we get 5x equals 20 plus 4y. Second equation, we rescale by multiplying by 5, and you get 5x equals 4 times y plus 10. Well, at least that gets rid of fractions. However, let's distribute this a bit. So the first, let's transpose the 4y to the left in the first equation. So 5x minus 4y equals 20. For the second equation, we'll distribute the 4 and get 5x equals 4y plus 40. Let's transpose the 4y to the left in the second equation. So the equations are now 5x minus 4y equals 20 and 5x minus 4y equals 40. We're trying to make poor old 5x minus 4y equal two different things at once, and it can't do that. And what happens if you continue with elimination and just subtract the equations from each other? And the 5x's cancel out and the 4y's cancel out, leaving 0. But 20 minus 40 is negative 20. And you get 0 equals negative 20, which it isn't. So we assume the system and get an absurdity, which proves that the original system has no solution. Then in fact, if you graph each of these two lines, you get parallel lines which do not meet. So, okay, we've had this gives a case. So if after the elimination you get 0 equals 0, that means overlapping lines. And if you get 0 equals non-zero, that means no solution. Here we have a problem which we've already done the same sort several times already. Find two numbers that sum to 34 and differ by 10. All right, we're a simple word problem. Let x be the larger number and y be the other number. The sum x plus y is 34. The difference, x minus y with a bigger number in front, x minus y is 10. So x plus y is 34, x minus y is 10. Now we can solve by elimination. If we add the equations, the y is canceled. So you get x plus x is 2x, y plus negative y cancels. 34 plus 10 is 44. 2x equals 44, so x equals 44 over 2. So x is 22. If instead we subtract the equations and x minus x cancels, y minus negative y is 2y. 34 minus 10 is 24. Oh, y minus negative y is 2y because the minus negative cancels. I get y plus y, and that's 2y. So 2y is 24. Divide by 2, y equals 24 over 2. So y equals 12. So the solution is 22 by 12. And okay, it doesn't really matter which is first and which is second. We wanted two numbers. Their sum is indeed 34, and their difference is indeed 10. And that concludes that part. All right.